Morning, everybody. Who's BGO318?
Morning. Malay.
Oh, hey, Malay, what's going on?
Malay.
Yeah, I know. I got you. What's BGO mean?
Pretty good.
Yeah, but why does it say BGO? What's that mean?
Blue, green, orange.
Oh, I see. Cool. All right, we'll start in a few minutes. Be right back. Of course, I'm going to start early. How's everybody doing today? Let's see who we got. What's going on? Everybody happy this morning? Hey, good news. Going back to school tomorrow. April Fools. Let's first of all let's clear a few things up. Here's what I heard. Probably there are no finals. Okay, I think that's on the way out. I don't think they're gonna have finals. Probably. Well, we're definitely going to be here until about the end of April. They said April 30th is when the next big to do is going on, and there's a big meeting today. That's above my pay grade. I don't know what's going on in the meeting, but that one, and then we'll know about AP stuff on Friday. I talked to one of the big AP people, and it's looking like the test is going to be, well, they're going to have it, like our regular test days. I don't know when, but maybe it'll be all at the same time. Maybe just like released and posted. Maybe it'll be, you could take it whenever you want. It's going to be in May. They're not talking about moving it up earlier. They were actually talking about moving it later, further away. But we'll see. We'll just play that and see how that goes. All right, today's assignment is, well, besides going over some of the problems, which is what we're going to go over, you have to say something. I just want to make sure people are on the stream. Okay, people are actually involved in this. So I'm checking you off. So if you're around right now, who do I got? Jackie, Ian. I'm just marking people off that. Snea, I got you. And if I don't know who you are, there you go. Who we got? Snea, then Dina. Oh, I need my glasses on. Sorry. Look at everybody's here. Good job, guys. Some of you aren't talkers, but see, that's easy. Got that. Hold on. Oh, now we're going too fast. Wait, Hassan's alive? Hassan, I got Hassan. Who else is here? Mona. I'm just marking people off because, and if you're not in the stream now, just post something in the comments, and then I'll be able to mark it off. Just to make sure everybody is participating. Remember the plan. Okay, we're just going over problems. I'll have more accurate problems, like free response problems, by the end of the week and next week. But right now we're going over just multiple choice. You could cover a lot of material there. Joey, I got you. Hold on. Did I miss somebody? Snea, Azan, Mona, Joey. Just marking people in here. And then we'll start going over some problems. So be ready for that. See, I got everybody in 2 different classrooms. I should have put everybody in the same classroom. Sebastian, Mia, I got you. Zoe. Who else is here? And don't worry, I put away chat. Malay's here. Tars, Malay, got you. Look at everybody's on. I was like, oh, not a lot of people are on. Maddie, I'm on. Who else? Aisha, Mike. We got, who else? Who am I missing? I think I got Kia, June. All right, I think I got everybody that's here. Anybody else say anything? Anybody else in chat that's not here? Besides, let's see, Sophie, Gavin. Those are the Sophie, Gavin. All right, so I just marked down now if you're not here, okay, and then make sure you post something in chat. I want to make sure everybody is. Oh, Ria's here as you come in, and we'll do one more round. Did I get everybody? I think I got everybody that said something. All right, so here's the plan. I was gonna, people posted some questions. Okay, people posted questions, and I see you there. Of course, late. Just kidding, buddy. Not really. Right now, let's go over as many questions as we can go over here. So, does anybody, whoever's in chat right now, whoever's in chat, anybody have a question? Don't be selfish. Say, hey, let's go over this problem. I know a couple people. There's a couple ones I was talking about, but like that first one that I posted right up there, number 22. Let's start there as you guys get warmed up and want to do some problems. Take a look at number 22. Okay, and that's a good one because that's on the objectives here. Let's change it up. Take a look at. We're going to do 22. Okay, if you're following along. Okay, you could pull it up on the PDF that I put online. Okay, 22, it says we got a differential equation. It's number 22. Okay, on our differential equation, we got, let me move the mic here. We got dy dx is equal to 2y over 2x plus 1. Okay, and then we got initial condition. Okay, we got y of 0 is equal to e. So we want to find the equation. So right away, you got to recognize that we're talking separation of variables. We're talking differential equation. The key hint on the problem is this is a differential equation. Okay? So we got to recognize that now. What do we have to do? You could talk in chat too if you want to voice any opinions or anything like that. If you're in, on Discord. Okay? We got a differential equation here. We got to do separation of variables. Okay, so get all the y's on one side, get all the x's on the other. And remember here, no adding and subtracting. So you should look at your binder. Oh, I also heard they pretty safe bet that the AP, your actual AP test is going to be open notes. They're going to allow you to have your notes. So here's the binder ready to go. Okay, that's not an April Fool's joke. That I did hear. It's more and more people are. I mean, they can't keep you from it, especially if you're doing it at home. So I'm thinking it's going to be open notes. Okay, so that's where your binders. You have your binder organized, that we've been doing all year. You are in great shape. So right now you open up to differential equations. You do some separation of variables. That should be right there. Okay, so get all the x's on one side. So I'm going to put dx on this side because cross multiply. Make sure you have it in your binder. No adding or subtracting. I'm going to leave that 2 there. 2x plus 1. And on this side, I get all the y's. 1 over y dy. I could have moved the 2, but like I said, we're always trying to solve for x. I'm sorry, get y by itself. So if we're trying to get y by itself, it's just much easier to, keep it as small as possible. Okay? So now we're going to integrate. Of course, I'm going to do u substitution there. Remember, natural log. Don't fall for that trap. Is there chain rule? There is chain rule. Du dx, 2dx. You see what I mean? So I got dx is equal to du over 2. So there's where that 2 is helpful for me. So I got natural log of y, absolute value. We got, let me just show that. Take the 2 out, 1 over u du over 2. So notice the 2's cancel right there. You see that? So we got natural log of y is equal to natural log of u, which is our 2x plus 1. And then there's our plus c at the end. Don't forget the plus c. Have your binder ready to go and have your binder taking notes, especially since the AP is going to be open notes. Just there's a plan. There's a procedure. You see that? Any questions so far? Okay, so now right at this stage, let's plug in the initial condition. Okay, initial condition was 0 for x, y was e. Okay, so natural log of e, I should have absolute value around that. Natural log absolute value 2 times 0 plus 1 plus c. And take a look. What do we got here? Natural log of 1. So c is equal to 1. So now we have natural log of absolute value of y is equal natural log absolute value of 2x plus 1 plus c. Oh, plus 1. I just solved for c. Plus 1 right there. Okay? So did everybody get that far at least? Okay, so now it's, well, how are we going to get, what are we going to do here? How are we going to get y by itself? Okay, so here's where they take the e to both sides. Now, how does this work here? Remember, this is where the problem is going to get a little tougher. You see, as we take e to both sides, you see that? As we're going to take e to both sides on there, how does this simplify? Remember this canceling part. Okay? Remember what's going on there. We got this cancels, so we got absolute value of y. Now this here, this, remember, plus in the exponent is, let me show that extra step. Plus in the exponent is times when we're separating the e's. Remember, that's algebra 1 property right there. Wait, we're not a room here. So I have, can you see that? So I have absolute value of y is equal to, now those cancel, absolute value of 2x plus 1 times e. Okay, so hopefully right around you're looking, I'm thinking b. We're looking at b. No square root showed up. Yeah, there's absolute value. We'll have to deal with those absolute value. But hopefully you're looking at b right now. Now, how do we confirm that? Well, plug it in. Plug in the initial condition. Okay, when x is 0. Oh, I can't see that. When x is 0, y is e. So we plug in 0. Hey, look, we plug in 0. We get e. But remember, this is both sides absolute value. That's why they gave you, if you look on the problem, okay, that's why they gave you, if you take a look at the problem, you see that? They gave you this domain restriction. X is greater than negative 1/2. The reason why they did that is because there's absolute value on both sides. Okay, so when x is greater than negative 1/2, there's no way this absolute value needs to come into play. So that's why you could just get rid of that absolute value for the domain if that was bothering you, if you were wondering why they're saying that. You don't need the absolute value on that side. So now, clearly, hopefully clearly, when you plug in 0 right there, you get positive e. You don't need the absolute value on that side either. And then there's where the answer comes from. Now, a lot of people got that wrong, so if I missed what you were confused at, okay, you got to say something. How do we feel there? I know there's a 10-second delay, so I'll wait.
Mr. Nunn,
Yes.
I had a question. Do you know if the online AP classroom is the same as the PDFs you give us?
The one that the question that Ian asked was, is the online test the same as the PDF I gave you? The very first one, the first day, I put the wrong PDF up there. So now the PDF that you have up there is the same as the online PDF questions. Okay, so it's if you just grab the very first day and you print it out or something or downloaded it changed that. Do the one that's up there right now. Okay, the problem was I put an AB for everybody, so I posted BC incorrectly the first time. So the one up there right now is the correct one, and I think the one on Schoology it says AB. Let me double check that. The one inside Schoology, it says, just double check for you. Yeah, I think it's the correct one. That should be the one under e-learning week 1, and it says practice test AB. Yeah, that's the correct one. That's the one we're going over right now, and that's the one that you took online.
All right. Just my 22 was different, I think.
Right. That and yeah, the 22 for the, like I said, the first PDF. I unpublished it, but the first one that I gave you, it was a different one. You're right. But the one online and this one should be matching up.
Okay. Thank you.
I don't know. We set the integral of y. Okay, so we'll take a look. Let's go back up to here. And we got to do separation of variables at this point. So here's the original equation that they gave us. Okay, that's the original equation. And we want to solve for y. Now to solve for y, we got to do separation of variables. You got to recognize that right off the beginning that this is a separation of variables problem. They gave you a differential equation. It has both y and x mixed in. Okay, so then you got to say, oh yeah, that's a differential equation, we call that. And so therefore we're going to separate variables. Okay, so how do we separate variables? You're only allowed to add or subtract. So when I'm sorry, let me say that again. We're not allowed to add or subtract. We're only allowed to multiply or divide. So we cross multiply is usually what we do. So that's where we came from this step right here. That's where we came to when the x's, see how this x is going to go up there. The dx, so if I take that, show that extra step, I got dy equals 2y over 2x plus 1 dx. That's where I'm at right there. That's that little extra step there. And then we say, oh, no, we don't have all the x's and all the y's separate, so now we got to move that y down here. Again, not allowed to add or subtract. We're only cross multiplying. So I divide both sides by y, so that canceled and it moved down there. So that's this stage without the integral. That's where we're at. Is that the question you were asking, Dina? Right there is the 1 over y equals 2 over 2x plus y, and then the dy on that side, the dx on that side. So there's the separation of variables part. Now all we got to do is integrate that. And once we integrate that, you follow the plan. I had to do u substitution on this side. I got a natural log on this side, and et cetera, et cetera, et cetera. So that's the initial part of separating the variables. How we feel on this one? Okay, remember, no speech. I promised I wouldn't be speeching, but I'm going to give you a speech. Now more than ever, there's no finals. You know, all my grades are as if you're participating. Okay, so it's this is where it builds some character. This is where it's on you. Okay, so there's nothing. I mean, and grades too. I posted grades. A couple people have been emailing me. Check those grades because that's what I feel the grades are at this point in time, and I'm thinking that's going to be the grades for the end of the semester. Because there's a lot of, the governor came out and said he doesn't want e-learning to harm people's grades and stuff like that. And Harper, I haven't heard from Harper yet about if you're involved in a dual credit class or anything like that. But we're trying to keep it. This is a stressful time for a lot of kids. Maybe you guys are handling it better than other kids, but I have other kids that are not handling this very well. So don't, and like anything else, a couple people were all worried when that lockdown manager didn't work. You got to take stuff in stride and work through it. But your goal is to get a 5 on the AP test. So let's not worry about grades, but check your grade because I think that is the final grades. If I was going to give a final grade, I don't know whether we're still things change. I get a different email from one day to the next day. So I don't. You know me. I'm not really worried about grades. Okay, but look on there because I have to post something. And so all my things I'm posting now for e-learning day 1 and day 2 is just participation. Are you involved? And that's really just to keep you going. It's to keep you motivated. Okay, but I mean, I could keep you motivated. I have jokes. But you have to have some type of, desire and some type of initiative to work here because there's no one standing over your shoulder. Maybe your parents are. But there's no one standing over your shoulder to get you to do this. So I told Miss Snow I wouldn't give a speech. But remember, this is what's integrity and character. This is where you got to be right now. Okay? So Beth said we want to do 23, and then a couple people were talking about 3. So let's go 23 first, since we're right there. And then we'll do 3. 23. All right. So now remember, 23 is not on the AP test for AB. but we're all taking BC, so we'll be okay. But an AB, I marked some of these down. That is not an AB question because the AB stopped at differential equations. But for you guys it is, so let's work through that in case you're talking to some friends who are in AB class. Okay, so we're doing 23. And 23, we got the region. Okay, and it's no calculator, so we got to be able to get a picture of this. A parabola should be pretty easy. We got the line 2. Okay, so definitely see some intersections there. There's the base of the solid. Let's pick some points, 0, 0, 2, 4. You should be able to produce that, okay, without a calculator. And then the cross sections are rectangles. Okay, now remember, here's where the practice, again, you should have your binder open because when you come across a problem like this, I mean, think about it, the test might be timed. I don't know how they're going to do it, the actual AP test. So you got to be tab right over to your binder, and then this will help you. Okay, so that says the rectangle, the height, so we'll call this the base, and at the height. And right away, I know my integral is base times height, and as we always say, dy or dx. Let's see. Perpendicular to the y-axis. Okay, perpendicular to the y-axis. So I'm going to draw my practice rectangle perpendicular to the y-axis. So right away, okay, there's a bonus. Whoever says the answer first. Is it dy or dx? As I take a Diet Coke.
dy.
I got a dy. Let's see if anybody posts in the chat. dx? dy? Who's right? Maddie or Sneha? If it's perpendicular to the y-axis, it's dy. If it's perpendicular to the x-axis, see, take a look at where our practice rectangle is going. Okay. Do you see why it's dy? All right, here's your bonus, Sneha. Ready for the bonus? Okay. What did the olive say when it fell off the stool? Olive. It's dy. So, base, the height, is 3 times the base. So that could change my equation to 3b squared dy. Everybody see that? But still, remember, here's how we did it. Okay, the way we did it is we said, all right, this is as far as I can go with this one. Okay? But I can't, this is y, and this is b. I cannot integrate yet. You got to always think like that. So now I'm over here, and what is that little practice rectangle? That's how we worked it out. We said that practice rectangle is bigger minus smaller. It's always a distance, but remember, it's in y. So I got to change this. This is x equals square root of y. And this one is x equals y over 2. And like I said, bigger minus smaller. Square root of y minus y over 2. That's what that practice rectangle, that's the distance. That's what that practice rectangle is. You see that? You got to remember that when it's horizontal. And that's matching up with that base right there. And so that's what gets us our equation. So I say smallest y, biggest y, 3 square root of y minus y squared dy. And now we're just trying to match up with whichever one the rectangle says. So whichever one the AP problem says. So the first thing, and this is what we're right away when everybody's saying dy, the first thing we want to look at is right away, it cannot be C or D. I gotta make, that just makes my life so much easier when I remove that. And then you say, all right, bigger minus smaller. Always bigger minus smaller. There's our answer. Okay, there we get for A. Beth, you asked about this one. Did that make sense? And then we'll go to number 3. People are asking about number 3 and number 5, I heard. And Beth said, just keeping track of these. Like, while people are on, we're going to do the ones. Okay, let's do number 3. Hold on a second. Yeah, let's do number 3. Okay, 3 says, okay, so we got to just take the derivative. And let's watch our signs. Let's be careful about this. F of x, 5 minus x. Right away I'm looking at that and I'm seeing chain rule right there. Are we remembering chain rule? We're going to quotient rule with, right there, this negative is going to be a chain rule. So low f prime of x, low x cubed plus 3 d high. Now here's where that negative comes in. The derivative of the top is -1 minus high, 5 minus x, d low. All right, the derivative of the bottom is 3x squared. All over low squared. Okay, there's that first step. How's that on number 3? And then we got, let's try to match it up. Notice the top, the bottom, it's squared, so none of the bottoms. I looked at the bottoms first, and the bottom looks pretty good. Isn't it? Cube plus, did I write the problem down? Oh, it's 2. I'm sorry, I wrote the problem down wrong. 2. There you go. Yeah, 2, right? X cubed plus 2. So I distribute the top, negative x cubed minus 2. Here I distribute the bottom with that minus. Maybe take an extra step if you know that minus signs are going to get you. So this is 15x squared minus 3x cubed. Maybe take that little extra step. And the bottom's the bottom, x cubed plus 2. And then, let's see what we got. Distribute this minus through. If you know minuses are kind of messing with you. Plus 3x cubed. Bottom stays the same. We don't even have to worry about the bottom. All the bottoms are the same. So now, what do we got? Combined like terms. There's where we wind up with the positive 2x to the third. So positive 2x to the third, and then copy everything else down. And then you get your answer, C. How do we feel on C? Everybody okay there? Did you find your mistake? It's really just kind of a straightforward. How's the arithmetic there? Is it okay? All right, let's do number 5. 5's another one where let's just be careful. Let's just make sure on number 5. Let's just go slow. Go slow and make sure we got sine, a little trig here. Sine of x squared plus pi. This is number 5. We want to take the derivative, f prime of x. Now we got a little chain rule here. So I'm going to take the derivative of sine, cosine, keep. There's my keep part. And then times chain rule 2x. You see that? Now you could do some algebra to simplify, or you could just plug in square root of f prime of square root of 2 pi. So I got the cosine. I got square root of 2 pi squared plus pi. Remember, no calculator here. 2 square root of 2 pi. Notice right away I'm looking at that square root of 2 pi is not going anywhere. Okay, so I'm looking for the one that has that on there. Let's see what happens in here. Cosine of square and square root cancel. We got the plus right there. 2 pi plus pi. We have 3 pi times 2 square root of 2 pi. So now take a look. If I'm looking at my choices here, this is not going anywhere. So I could work a little smarter here and say, well, it's got to have a 2 square root of 2 pi, and the cosine is going to go away. This cosine of 3 pi, it's either going to be 1, -1, or 0. We know how that works. So right away, I'm just guessing A if I'm stuck here. But cosine of 3 pi is the same thing as cosine of pi. Think of it like that. Okay, cosine of pi is -1, so there's our answer. -1 times 2 square root of 2 pi. That was number 5. Check your arithmetic there. Remember your trig on something like that. And then I want to go over, we're talking about number 28. Okay. Let's go 28 first and then 29, you say? Okay. Let's do 28 since we're on the same page there. We'll do 28. All right, we got an isosceles right triangle with legs of length S. Okay, let's just draw the picture. Visual guy, S and S. Isosceles right triangle, those legs are S. We know this is S square root of 2 because it's an isosceles triangle. Wait, what's that? Isn't the answer choice to number 5 2? There was a typo. Oh, it didn't have the negative. Okay. Let me take here. Let's look at the. Hold on. Let's see. We're back to that problem. Okay. For the online test, there's a typo. Here was that was number 5. Here, let's look at number 5. Okay, number 5. I printed out the actual test for the PDF. Okay. So the actual test was negative. So you're saying on the online one, you just didn't see that negative right there. A -2 in front of that is why you don't see the. Oh, okay, I see what you're saying. Yeah, that could be. Okay, it didn't have the negative in there. All right, that's the online. I'm gonna post the PDFs. We're gonna work through the PDFs because that plus you're getting on the lockdown. The manager that app is causing a lot of trouble. So we're gonna go from the PDF from now on. Yeah, I don't want you guys getting all messed up, especially when you got the answer right and you can't find it. Let's go back to number 28. All right, let's see. So here's our equation, the area. They gave us that 1/2 S squared. Looking at 28 here. Yeah, go off the PDFs. When S is equal to square root of 32, the area of the triangle is increasing at a rate of, hopefully we're all pretty good, the area, dA dt. It's rate of 12 in units, square centimeters per second. Okay, so that's where I got that from. At what rate is the length of the hypotenuse? Okay, so let's go the hypotenuse. In this case, well, let's just call this h for hypotenuse. They're asking for dH dt. Okay, at what rate is the length of the hypotenuse increasing at that instant? So that's what they're questioning. Everybody see that? So they got the area. This is the hypotenuse, which we know, and this is the key. We know that's S square root of 2. So if they're asking for dH dt, I could right away find dH dt. Okay, and dH dt, if h is equal to S square root of 2, dH dt is equal to ds dt times square root of 2. So really we just have to find ds dt. And then we multiply it by square root of 2 to get the answer. Everybody see? Okay, but all they gave us is the area formula. Okay, so if the area formula, okay, we have dA dt, I'll take the derivative, is equal to, we'll drop the power down, S times ds dt. Everybody see? So plug in 12, plug in square root of 32, that could find ds dt. ds dt is whatever, since there's no calculator. ds dt is whatever 12 divided by square root of 32. Now I have no calculator, so I'm not going to try to simplify that. So then I could come back up here and say dH dt is what the question was asking, is equal to 12 over square root of 32 times square root of 2. Now I'm looking at the multiple choices. I'm going to just try to match up with that. Okay, so let's see. Square roots I could cancel. So now I cancel that, cancel that. I got square root of 16. Oh, I know square root of 16. Square root of 16 is 4. 12 divided by 4. There's our answer, 3. Notice also, since you got the PDF, the answers are in the PDF. So if you scroll to behind past all the questions, you could see what the answers are if you want to check your work on something like that, if you're not sure. If you're using the PDF. You should use the PDF. Don't do all the online stuff. How was that? Number 28. Yes, that's where you'd file this. This is a related rate problem because they're giving you an equation. We have like a formula, and they gave you information. Here's the information that they gave you in the problem, and they give you the rate of change of area, and they're asking you for the rate of change of height. I'm not a hypotenuse of the hypotenuse. So yeah, we're dealing with the rate of change. So, but look at where the tricks come in. Okay, you gotta find, if they say like right away I put s square root of 2 right there. But the question was, what's the rate the hypotenuse is increasing? So I got to call that h also, so I could see what I'm talking about. So look at how I had to take two derivatives in here. I had to take this derivative in terms of s to get that equation, and then I had to take this derivative in terms of s also to get that equation, and then I could connect those two together. Okay, so I started with s. And I said, all right, this is S, this is S. It said isosceles right triangle. So I right away I didn't even know if I needed this. I wrote S square root of 2 right there. Okay? And so then they gave me this equation. Area equals 1/2 S. Here's the information they give me. And then right here, the question, I found out what the question was asking. The question said, what is the rate of change of the hypotenuse of the triangle? So right away I'm looking for a dh dt. The rate of change, that's why I have a dt down there, dh dt. And so that's right here, okay, is where that connection was made. This is the hypotenuse, but this is also s squared root of 2 from a 45, 45, 90 triangle. So that equation is what I go to first, because I want to find dh dt, so I find an equation that has h in it. So I could take the derivative and find dh dt. Okay, this equation has h in it. H is equal to s squared root of 2. Notice they expected you to know the 45, 45, 90. So I took that derivative. I don't have ds dt. So I cannot find dh dt. So I got stuck right there. So then I get this equation, because that equation is going to get me ds dt. Because they gave me dA dt, they gave me s. That equation gets me ds dt there. Once I solve for ds dt, I plug it back into here, which this is where I got stuck at, and then just do a little algebra to find that. Aman, did that make sense? You see how we walked through it? But the progress is what we got to pay attention to. Find an equation that has what you're looking for in it. I'm looking for the hypotenuse. So I found an equation that had the hypotenuse in it. I could have done Pythagorean theorem also. Okay, s squared plus s squared equals h squared. And taken that derivative. But notice, whatever I did, I would have gotten stuck and said, I need ds dt. So that's where this part comes in. Also, everybody's got to think, the AP, the nice part about AP is they don't give you useless information. So you got to say, why would they give me dA dt? So I'm going to have to take that derivative at some point. We're going to move on to 29. Take a look at 29. All right, now here's, again, asymptotes. Asymptotes, you have no calculator, and you get your binder. Make sure you remember how the asymptotes go. One horizontal asymptote and one vertical asymptote. So you should be looking in your binder right now and remembering how do you find horizontal asymptotes, how do you find vertical asymptotes. Okay? Horizontal asymptotes is end behavior. Horizontal is top, we always call it top heavy, bottom heavy, even, bottom, even. This should be in your notes. Even Steven, we said, for horizontal asymptotes. We take the limit as x approaches infinity of our y. We take the limit of the equation. Okay? And if it's top heavy, there is none. If it's bottom heavy, it's 0. Even Steven, it's the coefficients. Just quick review of horizontal asymptotes. Okay, so I look at these. And I go, all right, well, that's bottom heavy. Is that? That's bottom heavy. So there's 0 horizontal asymptote at 0, horizontal asymptote at 0 right there. Okay. Well, what about that one? What about E? Okay, as E goes to infinity, take a look. As E goes to infinity, taking the limit, this goes to infinity. I got 1 over infinity. I got 0. So technically that's bottom heavy also, and that's bottom heavy. You see that? So all these have one horizontal asymptote. Okay, so now, how about a vertical asymptote? Where does vertical asymptotes come in? Vertical asymptotes is where the denominator equals 0. That's where we get our vertical asymptotes from. Okay, so I could check each one of them. Take a look at A, x squared plus 1 equals 0. And B, x cubed plus 1 equals 0. And C, e to the x minus 1 equals 0. And I'll put D on this side. D, e to the x plus 1 equals 0. You see, a vertical asymptotes is where the denominator equals 0, but not, let me do an extra, not the numerator. Not the numerator. I kind of spelled that wrong. Not the numerator. Let me show you what I mean. If I got x squared minus 4 over x minus 2, the denominator equals 0 at 2, but the numerator also equals 0 at 2. So that's not a vertical asymptote. Okay, x credit. What is that then? The denominator equals 0, but the numerator is equals 0. You get a bonus. First one to say it. Yay, Jackie said it. Let's see if anybody else says it. Because shouldn't it be a W-H-O-L-E? All right, Jackie, here's your bonus. What did the red light say to the green light? Hey, don't look at me, I'm changing. All right, so there's the denominator. We're going to see where the denominator equals 0. Notice all the numerator is 1. So we don't have to worry about the numerator. I solved this one, x e to the x equals 1. No problem there. That should be, okay, that should be, hopefully that should be easy. 0, right? Okay, solve this one, x cubed equals negative 1. Can x cubed equal negative 1? Yes. If I take the cube root of both sides, what's the cube root of negative 1 is negative 1. You see, that's no problem. Okay, so what about this one? X squared equals negative 1. Ah, okay, x squared equals negative 1. That can't happen. Imaginary numbers right there. You see that? So right away, this has no vertical asymptote. We feel okay there? Does that make sense to everybody? Okay, so no vertical asymptote on that one. We can take a look at the graph if you want. Yes, is that okay? Is everybody okay there on that one? So look at our rules, look at our definitions. Okay, horizontal asymptotes, it should be in your binder. Top heavy, bottom heavy, and Steven. But technically what we're doing is we're taking a limit as we go to infinity. So you could always take that limit to see what's up. And then vertical asymptotes, the denominator equals 0, but not the numerator. If the denominator and the numerator equals 0, it's a whole. Okay? All right. Let's stop for today and let's tell you your assignment. Now, here's what I need to do. There's still any we have not covered under no calculator, okay, post that in Schoology. or put in the comments down here. I'll take a look at that if there's one that we still haven't talked about. Or tomorrow when we get online, you could say I still want to do a no calculator one because we'll go over those. I marked down who was here. Okay, if I did not, mark you down. I think I got everybody that was here. I know Cedric came in a little later. Okay, so I marked down who was here. And if you're watching this later, like if you're a late sleeper or something, just post in the comments and just say hi or say the problem numbers that you want to do or say, I'm good. Because I want to mark down, I want to take a look at who's actually participating. Okay. Oh, Ryan's here. Let me get Ryan in there. And I got Cedric. I know Cedric came in. If you came in halfway through the day, you could say something now so I can mark in. Who do we have? Here, we'll just put it underneath here. So if I missed your name, take a look at you. Bea, I think I got you. Did I get you, Bea? Nope, sorry. Okay, take a look at your name. There's 8th hour. You could pause the screen and double check. And if you don't see your name, then post in the comments or say something right now. Here's 1st hour. Sarah, gotcha. Here's 1st hour. Take a look at 1st hour. So if you don't see your name here, then post in the comments or say something right now because I want to check to make sure you can get on the stream and are following along and stuff like that. Okay? All right. I'm going to go to AB now. So I will log off. And remember, you could always email me during the day if you're working on a problem or something like that. Just email me and say, Mr. Noah, I want to talk about this one. And I thought I got you. I marked you down. Okay. So if you send me an email during the day, I'm really just here in the house and getting yelled at by Mrs. Noah all day long. So just give me a chance to get a little distracted. Okay? All right, everybody have a good day. And remember, check your grades online. I feel they're completely updated, but if I miss something, send me a message. And I'm thinking those are going to be your grades. Okay? Those are going to be your grades for the school year. So you better double check that. Okay? And then, like I said, I found out there are no finals, so you don't have to stress out about that. AP, I don't know. This week we'll know a little more about AP. Okay? All right. Have a good day, everybody.